Hi, in this video we're going to look at some more questions from the Maths Admissions Test for Oxford and Imperial from 2016. In the first video I answered questions A to E and talked a bit about the paper, so in this one we're just going to get straight on and look at the next questions. We'll do the rest of the short answer questions in this one. So we'll start here with question F. It says, let n be a positive integer, then x squared plus 1 is a factor of this expression, and we need to decide, for which values of n that's true. Is it all n, just even, just odd, no values of n, or n larger than or equal to 3? Now from AW you should be familiar with the factor theorem, that says things like, x plus 1 is a factor of a polynomial, if and only if x equals minus 1 is a root. Okay, I'm just stating this as an example. You can change 1 here to a and x and this to minus a, and this is kind of like a generalization of that we're using here. So what would it mean for x squared plus 1 to be a factor of something? X squared plus 1 doesn't in itself factorize, so we can't have just linear factors. But again, if x squared plus 1 is a factor of a polynomial, that means I could write it as x squared plus 1 times some other expression here, some other polynomial here, so let's just call it f of x, that would be equal to 0. So it means that this expression here, x squared plus 1, would be equal to 0. Okay, so that x squared would be equal to minus 1 here. Now we notice in the expression that everything is a function of x squared as well, which is helpful here. Okay, so x to the 4 is just x squared squared, right? So we can think of this as 3 plus x squared squared to the n minus x squared plus 3 to the n times x squared minus 1 to the n, and then substituting in x squared equals minus 1, this becomes 3 now plus minus 1 squared to the n, so that's 3 plus 1 to the n, and then we've got minus, now x squared plus 3 to the n, that's minus 1 plus 3, so that's 2 to the n, and x squared minus 1, so that's minus 2 to the n there, so I've got 4 to the n, and then let's just leave that as minus 2 to the n times minus 2 to the n, and we would want that to be equal to 0. Okay, so well, 4 to the n minus 2 to the n times minus 2 to the n, so 2 to the n times 2 to the n would be 4 to the n. Now if n is an even number here, then minus 2 to an even power is just the same thing as 2 to that power, so this whole expression would be the same as 4 to the n, so we'd have 4 to the n minus 4 to the n equals 0, and that would work. Whereas if n is odd, then we'd actually end up with 4 to the n plus 4 to the n here, so that wouldn't be 0. So the answer here is that it just works when n is even. Okay, so just to be super clear here, I suppose I could say, when I state the factor theorem here, x plus a is a factor of p of x if and only if x equals minus a is a root. I should perhaps say something like of p of x equals 0 here, right? Which is why I have equals 0 here. So I'm sort of now thinking of this as an equation, equal to 0. X squared plus 1 is going to be a factor of this expression if x squared equals minus 1 satisfies this equation. Okay, so good to be clear in your mind about the difference between equations and expressions and when we're using one or the other. Okay, let's go on to the next question here. G, the sequence xn, where n is greater than or equal to 0, is defined by x0 equals 1, and then xn is defined by this sum, so it's a sum from k equals 0 to n minus 1 of xk. So what that means is, say, for example, let's just think about what this would mean for just a typical value here. So let's just take x3. Okay, you could do this with any value of n. Yeah, just switch to the other side of the screen here to hopefully help with the lighting. So x3 would be the sum from k equals 0 to 2 of xk. So what's that saying? That's x0 plus x1 plus x2. Okay. So in general here, x3 is just the sum of all of the terms that have gone before it. Okay, so I've got x0 is defined by 1, x1 is also 1, it's the sum of just x0, x2 would be 1 plus 1, which would give 2, x3 is x0 plus x1 plus x2, so 2 plus 1 plus 1 is 4, x to the 4, again, sum of all the ones before it is 8, and we see that the sequence just starts doubling. So it says here, can we work out the sum from 0 to infinity of 1 over xk? Okay, so what's that? What does that look like? That's 1 over 1 plus 1 over 1 plus 1 over 2 plus 1 over 4 plus 1 over 8, etc. So we see we've got term 1 here, followed by the rest of this, which is a geometric progression, with first term 1 and common ratio 1/2. So the formula for the sum to infinity of a geometric progression, a r to the n, that's just a divided by 1 minus r. So here the first term is 1, the common ratio is 1/2, so I get 1 over 1/2, which is 2. So actually I get 1 plus all of this stuff, which is 2. So the answer there is 3. I mean, you may be able to just see once you've written this much down that it converges to 3. And again, in fact, if you look at the possibilities for the answer, you may not need to formally go through the working out of the geometric progression here. Once you can see that 1 plus 1 is definitely got to be bigger than 2, so that rules out this one, and this one, and 27 over 5, that's bigger than 5. You can perhaps just see that that this is the only answer left that's sensible. And if you only get partway through this answer and you've got one that seems reasonable, then it's multiple choice, no working required, so you may as well go for it. Right, H. You notice these questions do get harder as they go through as well. I mean, it's definitely not, these questions are definitely not equal, right? I mean, the short questions get harder as they go on, so again, it's perfectly acceptable to skip over the last couple of harder questions, I think, and to move on to the long questions and perhaps come back to these depending how much time you've got in the exam. So two functions here, f of x is a minus x squared and g of x is x to the 4 minus a, and it says for precisely which values of a bigger than 0 is the area of the region bounded by the x-axis and the curve y equals f of x bigger than the area of the region bounded by the x-axis and the curve y equals g of x. So let's just have a little think about what those functions look like. So a minus x squared, so that's the minus x squared graph shifted up the page by a units, so we're thinking about this area here, and x to the 4 minus a, that's the x to the 4 graph shifted down the page by a, so that will be here at minus a, and this is the area that we're interested in. So I think here probably our best option is just to compute the areas using integration. It's not, it's a little bit awkward, but it's, you should be quick at these if you're taking this paper, and then you can just do the computation. So we do need to know where these hit the axis in order to do that. So a minus x squared, it's going to go from minus root a here to plus root a, and for x to the 4 minus a equals 0, that would give us the fourth, minus the 4th root of a as this point here, and plus the 4th root of a as this point here. So for our first area, in this one we've got the integral between minus the square root of a and plus the square root of a minus x squared with respect to x. And so if I just integrate that, a is a constant, so we have a times x minus x cubed over 3, and we do that between minus root a 1 plus root a. So substituting in here, now a times root a, that's a to the 3 over 2. Okay, and also the root a cubed is also a to the 3 over 2. So that's quite nice. We get minus a to the 3 over 2 over 3 here. Just a little bit of work with indices to fill in there if you need to. And then I subtract what I get when I put in minus root a. So in this one I get, again, minus a to the 3 over 2, and I've got minus a to the 3 over 2 over 3. Be careful here, so what do I get? Plus a to the 3 plus a to the 3 over 2, and that's divided by 3, of course. So here I've got, so in terms of a to the 3 over 2, I've got 1 minus a third of it, so that's 2/3 of it, and then here I've got minus 2/3 of it, but I'm doing minus, so it's like it's 2/3 a to the 3 over 2 minus minus, so plus 2/3 a to the 3 over 2, so that's 4/3 a to the 3 over 2. And then we'll do the same thing for the other integral here. So we've got minus the 4th root of a up to the 4th root of a, and this time we're going to do x to the 4 minus a dx. So I get x to the 5 over 5 minus ax between minus the 4th root of a and plus the 4th root of a. So again, we just have a little bit of work with indices. 4th root of a is a to the quarter, so when we raise it to the power of 5, we get a to the 5 over 4 divided by 5. And then this is a times a to the 1/4, so that's also a to the 5 over 4. It's often something that works out a little bit nicely in these questions, you see. And then when I put in the negative again, minus the 4th root of a to the power of 5, so that's minus a to the 5 over 4 divided by 5, and again here minus minus, so plus a to the 5 over 4, so a similar sort of form to what we had above here. So I've got 4/5 minus minus 4/5 in the same way as I had here, so this is 8/5 times a to the 5 over 4. Okay, so we've computed both of those, and we need to know when is the first one bigger than the second one. Oh, something to note here, by the way. Actually, this should be minus. So this is 1/5 minus. So okay, so strictly speaking, this is minus, right? So the integral is minus, but it's an area below the axis. So the area is plus that. Okay, so I do want plus 8/5 a to the 5 over 4 here is the area. So I want to know when is this first one larger than the second one. So when is 4/3 a to the 3 over 2 bigger than 8/5 times a to the 5 over 4? Well, let's just multiply both sides by 5 and then by 3 to clear out the fraction. So 20 a to the 3 over 2 is bigger than 24 a to the 5 over 4, and if we divide both sides by a to the 5 over 4, which is a positive number here because a is greater than 0, so then we would get, on the left hand side, we need to do a to the 3 over 2 divided by a to the 5 over 4, so we need to subtract 5 over 4 from 3 over 2. 3 over 2 is 6 over 4, so that's 6 over 4 minus 5 over 4, so that's just a to the 1/4. So I would have a to the 1/4 is bigger than 24 over 20, which is 6/5. So a is bigger than 6/5 to the power of 4, which is an option here, option E, which is then the answer to that question. Okay, so after I filmed the rest of this video, I realised that the video was getting quite long, and the last two questions take quite a long time to explain, so I've separated those out. Watch out for another video which will have the final two questions from the short answers coming up very soon.